Welcome to AI Frontiers. Today's episode, Cracking the Code, Machine Learning Frontiers in cs.LG, explores 123 groundbreaking papers released on December 9, 2025 from the arXiv preprint server's machine learning category. Prepare for insights into causality, trustworthy medical AI, and emerging trends shaping the future of artificial intelligence. This is your guide to the pulse of AI innovation. Every day, trillions of data points are generated, spanning from viral genomes to wearable sensors. Hidden within this data are patterns with the potential to transform fields like medicine, safety, and fairness. Yet, the very assumptions guiding our algorithms may be limiting our discoveries. By re-examining how these patterns are sought, new breakthroughs may emerge. The question is, what might be found if the status quo is challenged? Today's journey will traverse the landscape of modern machine learning, focusing on the cs.LG research domain. Foundational work and standout innovations will be highlighted, alongside the most urgent themes in AI research. Key findings and transformative papers will be illuminated, inviting you to imagine the motivations and perspectives of today's AI pioneers. Machine learning, as represented by cs.LG, serves as the conductor in the orchestra of artificial intelligence, transforming raw data into actionable insight. These algorithms, much like a child learning to recognize animals, adapt and improve through exposure to examples rather than rigid rules. The focus encompasses new algorithm development, theoretical analysis, benchmarking, and real-world applications. Each incremental improvement in this field ripples outward, enabling smarter technology and better decision-making. A central theme in this research collection is causal discovery, moving beyond surface-level correlations to uncover underlying causes. Bruguera and colleagues advocate for more flexible data assumptions, such as exchangeability, to better mirror real-world complexity. Representation learning empowers models to develop smarter, more meaningful data descriptions. This approach is analogous to detectives discerning not just who is present, but who influenced whom and why. Enabling AI systems to reason about causality rather than mere association. Interpretability, fairness, and trust emerge as critical themes as AI integrates into sensitive domains like healthcare and justice. Transparency becomes essential. Systems such as MedXAI, developed by Uruj and colleagues, are designed to explain their medical decisions. Research in this area seeks to reduce bias, improve user trust, and ensure clear, understandable reasoning. Much like an expert witness in court, who must provide explanations rather than mere assertions. These efforts aim to guarantee that AI-driven decisions are both fair and comprehensible. Efficiency, scalability, and robustness define another core theme. AI models now operate across a spectrum of devices, from supercomputers to smartwatches. Innovations like Aerial ML and Tiny Deja Vu demonstrate how advanced learning can be compressed into highly resource-constrained environments. Research focuses on increasing speed, optimizing memory usage, and ensuring adaptability to novel data, comparable to distilling the expertise of a master chef into a compact, portable form. The objective is to maintain performance while ensuring AI remains fast, efficient, and resilient to unforeseen challenges. Several key findings underscore these themes. Bruguera et al. Advance causal discovery using more realistic, messier datasets. Ali and collaborators introduce Murmur2Vec, achieving viral sequence analysis up to 99.8% faster than previous approaches. Uruj et al.'s MedXAI system enhances rare disease detection and builds clinical trust. Alice and colleagues demonstrate efficient learning from both labeled and unlabeled data, while Jahan et al. expose vulnerabilities in replicating safety-aligned medical models, highlighting the necessity for robust security and ethical safeguards. Turning to a particularly influential contribution, MedXAI, led by Uruj and colleagues, one finds the motivation rooted in a pressing need for trustworthy medical AI. Traditional medical AI tools often lack transparency and struggle to provide clinicians with explanations, undermining trust. This research team, combining computer science and clinical expertise, aims to support clinicians by developing systems that explain their choices with the clarity and reliability of an experienced practitioner. The vision is a partnership where AI augments medical decision-making rather than merely offering opaque predictions. MedXAI's approach is defined by a hybrid learning paradigm, fusing deep learning with symbolic clinical knowledge. The retrieval-augmented framework consults an extensive knowledge library to contextualize its analysis, while its self-verifying mechanism double-checks decisions before presenting them. This process mirrors a doctor seeking both a second opinion and established clinical guidelines. The resulting system generates explanations that are intelligible and trustworthy to medical professionals, bridging the gap between raw computation and clinical reasoning. The impact of MedXAI is significant. It achieves a 10% boost in rare disease detection and improves generalization across hospitals by 3%. These advances are accompanied by transparent, clinically aligned explanations that foster clinician trust. The team navigated challenges such as reconciling differing terminologies between AI and medicine. Ultimately, integrating symbolic knowledge provided a crucial anchor for deep learning models, setting a new benchmark for trustworthy and explainable medical AI. Looking forward, the trajectory of machine learning research can be likened to a river breaking free from its established course. The field is progressing toward algorithms capable of learning from imperfect real-world data. Flexible data assumptions and efficient data-sparse learning will assume greater prominence. The integration of symbolic knowledge and explainability is expected to become standard, while ethics, transparency, and inclusion will increasingly guide the discipline's evolution. In summary, researchers are actively discarding outdated paradigms, inventing models that are both fairer and faster, and establishing robust connections between human expertise and AI capabilities. Key challenges persist, including data scarcity, robustness to unpredictable situations, and pervasive security concerns. Nevertheless, the future will be shaped by collaborative efforts among people, data, and algorithms. Engaging with the latest literature may inspire the next crucial breakthrough. The synthesis of this episode has been powered by GPT 4.1 for summarization, with TTS processing and image generation facilitated by leading AI tools. All content has undergone expert human review to ensure clarity and accuracy, though some oversights may remain. Listeners are encouraged to consult original references for further detail. A complete list of cited works is provided for those wishing to explore the research in depth. Thank you for joining AI Frontiers. Stay subscribed for the latest updates in AI research and insights. From neural networks to quantum computing, everything is explained clearly and accessibly. The AI Frontiers channel is your gateway to cutting-edge developments in artificial intelligence. In this podcast, we bring you the latest breakthroughs in computer science and AI straight from arXiv, from neural networks to quantum computing. We simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.